Welcome back. We are going to do a real quick video about some polygon basics. I'm trying to shorten this so you guys don't have too much video-wise for tonight. So you probably have learned about trapezoids before. They have one pair of parallel sides. Real basic idea there. Something called a midsegment comes up occasionally. A midsegment connects the midpoints of both of the sides. So here's your midsegment. Notice it cuts this side and this side exactly in half. And so that is what a midsegment is. A midsegment will always be parallel to the bases, and its length is an average of the bases. Kind of interesting. So that will come up occasionally. It's a very specific fact of trapezoids, but it has come up, so that's why we include it. Isosceles trapezoids, the non-parallel sides are equal, and the base angles are equal. Okay, just some quick facts. This section might be easier just to, keep the notes page as reference, have the pictures, and look back at those as we do our practice problems tomorrow. Parallelograms have two pairs of parallel sides. So oftentimes, we note it with our notation like this. There are some interesting qualities. The diagonals bisect each other, which means they cut each other in half. If a parallelogram has all equal sides, we call it a rhombus. All equal sides. And so I'll use 3 tick marks since the picture already has other tick marks. So if you think about a parallelogram, inside that big group, you have the rhombus, which is a special type of parallelogram where all sides are equal. If you have a special type of parallelogram where all of your angles are equal, we call that a rectangle. Real interesting how they relate to each other. And then, just a small tidbit, the very, very meeting point of those two is what we call a square, a shape with all equal sides and all equal angles, which are right angles. Continuing on, kites. You've probably, have a good idea of what a kite is from flying kites or seeing kites. Kites have adjacent sides next to each other are equal, as are the other two sides next to each other. So you've got two pairs of adjacent sides that are congruent. If you look at this picture, it's got all the equal things marked pretty nicely. Some important things are, let's see, the diagonals are perpendicular. That's useful. Notice one of the diagonals, the shorter one, going across here, that is cut in half by the other diagonal, the longer one. Okay, so there's some interesting facts. There's also some other tidbits here. We can always go back to them during a problem if need be. Okay, and then we have 2 practice problems to look at real quick. So we have a parallelogram, MNOP, so I'm going to just draw a picture. So MNOP. Doesn't matter where you put the letters, as long as you go in a circle, either clockwise or counterclockwise, you're good. The diagonals, MO and NP, intersect at a point that they're calling E. And they're telling us that ME is 2x plus 9, and OE is 5x. What is the length of the diagonal MO? So this is bringing up, if we go back to the previous page, parallelogram property that the diagonals bisect each other and cut each other in half. So we could assume that 2x plus 9 is equal to 5x. If we solve that algebraically, we get 9 is equal to 3x, which means x is 3. However, double check what they asked us. They want the length of the diagonal. If x is 3, that is 15. So the whole diagonal is going to be 30 units, whatever kind of units they're using. And I'm just doubling that because I know that the diagonal is cut in half. If you plug in 3 into the green chunk, you should also get 15. So the midsegment of an isosceles, and remember we said the midsegment connects the 2 midpoints of the sides. We said it will be parallel. And if I call this A, B, and C, A plus B averaged is C. So that was some of the properties. And let's see, they're telling us They're telling us that the mid-segment is 4 centimeters longer than the shorter of the bases. So if it's in reference to something, I'm going to call the shorter base x, and then the mid-segment could be x plus 4. It's always easier to use whatever you're referencing, like if it's, some amount bigger or 3 times the amount, it's always easier to call that amount x. The longer base is 3 times the length of the shorter base, so we'll call that 3x. And we want the length of the mid-segment. Now notice they didn't give us very many pieces of information, and without knowing the fact that the base is averaged as a mid-segment, you'd be really, really off and confused. So we know that 3x plus x cut in half has to equal x plus 4. 3x plus x is 4x, right? 4x cut in half is equal to x plus 4. 4x cut in half should be 2x. So I know that 2x is equal to x plus 4. If I subtract x on both sides, we find that x is equal to 4. And then taking that, we want the mid-segment itself, so x plus 4 is equal to 8 units. Just plugging that in. Okay, so that is it for more polygons. We'll do some practice on that tomorrow.